Okay, guys. So this week, what we spoke about was the normal distribution, and we looked at two different types of functions that we go into the calculator to be able to calculate the probability or either get the value given the probability. So the first thing was normal CDF, right? So normal CDF, you needed to have a lower bound and an upper bound, right? Given some mean and standard deviation, right? So it can be a little bit tricky sometimes to find the lower and the upper bound, right? You just have to be able to draw a picture, and I think that's probably the best way to do that. So that you can go ahead and figure out which one is which. So if you are given a value and you want to figure out what the probability of this occurring, of this value occurring, you will want to use normal CDF. But if you are given the area instead, right, the area or the probability, and specifically it has to be to the left, and now you want to figure out what the value is, then you use the inverse norm function, which we use today. So all of the directions on how to use both of them are on Blackboard. So you can go ahead and look at the directions. Okay. So let's go ahead and do these problems so that we can go ahead and refresh our memories of what this was. So suppose that x is distributed normal with a mean of 15 and a standard deviation of 3. So we want to find either the area or the value associated with the area, depending on what they give us. So if you look at part A, right? Part A, they give us 17, right? So they give us the value, and now we need to figure out what the shaded area is, right? So when we are given the value and we want to find the probability, that's where we're going to use normal CDF, right? So here we are going to use normal CDF, right? So now here's where it gets a little tricky, right? Because you need to figure out where your lower bound and your upper bound is. Your lower bound, right? So where does it start? We always read this from left to right, right? So the lower bound, this tends to go to infinity, negative infinity, really, really, really small, right? So think of a really, really small negative number, right? So usually I would say negative 1 million, negative 1,000, whatever you want to go ahead and write, right? So you can go ahead and write that down. That's your lower bounds, right? So it starts from here, right? So wherever that is, which is really, really big, and it ends at 17. This is where the shaded region ends, right? So this will end at 17. So my upper bound now is 17. My mean is 15 because that was given to me, and my standard deviation is now 3. So all we got to do now is just plug this into our calculator, right? So I have my TI-36 here with me, so you can go ahead and follow along if you'd like. If I can figure out my life. Okay, so remember what you want to go ahead and press with your TI-36. You want to go ahead and press second and then data. So second data, then go to distributions, and then go to normal CDF, right? So now here, the mean, right, mu is just going to be equal to 15, right? So I'm going to go ahead and press 15. Sigma is going to be equal to 3, right? And then my lower bound, okay, you can just go ahead and leave it like that, or you can press negative 100,000 or whatever you want to go ahead and press. But it's already given to you in scientific notation. So then you just need to figure out what your upper bound is, which in this case, we wrote down that it was 17. And then enter, calculate, and ta-da, there it is, 0.7475, okay? So this is equal to 0.7475, okay? So that is the answer for this particular problem, okay? Now notice that this kind of makes sense because the mean itself is 15, right? So that means that the middle of the data is, this is 15, right? And since it's right in the middle, that means 50% of it is below it and 50% of it is above it. So 17 is a little bit more than 15, right? So it would make sense for this to be around 74%, which is higher than 50%. So that's how you can kind of check your work. Okay, now how would you do this problem, right? So let's go ahead and just set it up. So this will just be normal CDF again, because we are given the value, right? Now notice here now, our lower bound is now going to be 8, right? Because this is where we start. We start at 8. And we end at something really, really large, something higher than 8. So like infinity, right? So in this case, let's just put a million or whatever you want to write down. I don't know if that's what that is. But anyways, okay. Then our mean is still 15. And our standard deviation is still 3, okay? So how would you do this in this calculator? Well, now let me use my TI-84, right? So if you have this TI-84, right, then it's going to be a little bit differently, right? Because now you're going to go ahead and press normal CDF. So you're going to press second vars. Okay, then you're going to go down to normal CDF. Okay, and you're going to go ahead and press these numbers. So 8, comma, I'm just going to put a whole bunch of zeros there, 15, and then 3. All right, and what do we get? We get that. So 0.9902 approximately. Okay, so I'm just rounding to 4 decimal places. So that's what we'll go ahead and get. Okay, now notice here, if you may have the stats wizard, which means that you might have a much younger calculator than mine. Mine's a little bit older, so you might have a stats wizard. This one doesn't have it, but what will happen is that it'll you'll see like this screen that prompts you to put in the lower bound, the upper bound, so you don't need to go ahead and physically put it like this. So that's convenient. But anyways, okay. And now what we want to do is now these two problems. Now these two problems are a little bit differently, right? Because now these two, you want to go ahead and figure out what the value is given the probability. So they tell you this area is 0.9987, right? So this is where we're going to use inverse normal, okay? So this is going to be inverse normal. The probability and area to the left is already given to you. This is already to the left, so this is going to be 0.9987, right? And then what is the mean? The mean is still the same thing, which is just 15, standard deviation equal to 3, okay? So let's go ahead and put that into my calculator. So let me use this one. So I'm going to go second data, distributions, inverse normal, right? Area, and then remember this area is to the left, so this is going to be 0.9987. 15 and 3, everything's good. So my answer is approximately 24.03 around there. So this is 24.03. Okay, that's what we get. Okay, now this one though, this one we have to be very careful because now the area is no longer on the left hand side. That's what we need, right? It has to be, the area has to be to the left. So we need to make sure that this is to the left. So I'm gonna go, I want this area, right? Because it doesn't really matter if I take it to the right or to the left. If I find the area to the left, I'm still gonna get the same value of x. So I need to figure out what this red area is. Since I know that a density function has an area of 1, well, if I know what this is, if this is 0.76, then 1 minus 0.76 is gonna give me the area to the left, right? So I'm gonna go ahead and calculate that. So 1 minus 0.76 is gonna give me 0.24. So this is the area, or this is the value that I'm going to be putting in inverse normal. So I'm going to put inverse normal. Then I'm going to put 0.24, which is the area to the left of this. The mean is still 15, and the standard deviation is equal to 3. Okay, so what am I going to get? I'm going to use this one now. Okay, I'm switching back and forth to cater to you guys. So I'm going to put second vars. Go all the way down to inverse normal, right? I'm going to put the probability of 0.24, right, which is the area to the left, comma 15, comma 3. And then what is that going to give me? It's going to give me 12. So it's going to be 12.88 approximately, okay? All right, and that is my answer, okay? All right, so this was just a recap of what we did. Either if you were on my Wednesday or my Thursday class, right? So hopefully this helps a little bit more. In the next video, we are going to do this word problem. I will do it right now, but it would be a longer video, so I don't want to go ahead and do that. So read the word problem, right? See if you can figure it out, right? And we'll talk also a little bit about what this means, percentiles, okay?